Ihr Vortrag ist das solare Magnetfeld der Erde und das Erdklima. Oder darf man anders? Whatever, yeah.
Thank you very much to the organizers for inviting me to give this talk. It's a great honor to speak to such respected public. And I will start, you've been seeing a little bit mention about solar activity, but I will start from the basics. What is the solar activity? These are dark spots, which call sunspots. They're the current basis of solar activity index measured with the solar sunspot. They were built drawing by hand, and they built maps. Schwabe, middle of 19th century, and then Wolf, they built some kind of index and shown that sunspots appear on the solar surface periodically every approximately 11 years. What they discovered, that the sunspot number changes periodically about 11 years, having maximum, then minimum, and then again maximum, and all these cycles from 1 to 12 to now 25th. They also Maunder family, they shown that the sunspot occur on the top of the royal zone plus minus 70 degrees at the beginning of the cycle, and then slowly move towards the equator. These were drawings. At that time, people did not have any measurements of magnetic field, so this is the solar activity cycle which we inherit from the past. What happened in the modern era? We got nice satellites, we got magnetograph, and we started measuring magnetic field of the sun. And when you start measuring magnetic field of the sun, this orange disk, it turned out to be not simple like water flowing. It is actually magnetic field. We call it poloidal magnetic field of the whole sun. In this magnetic field, you have this magnetic loop which are buried or hidden with the roots in the photosphere. And these roots go in underneath, and the places where the roots start, they are seen as the sunspots. So this gives you some indication that the sunspot number indeed should be related to magnetic field, the magnetic field of this loop called toroidal field. So you have many of those loops which create active region and increase solar activity. So this is kind of how activity is linked, but you still see the discrepancy. If we speak about solar activity through magnetic field, why we measure sunspot number and group numbers? So this is kind of a little discrepancy. So in order to, look, this disappear. In order to understand what is happening, in 1955, great American scientist Eugene Parker invented the model of solar dynamo. He explained that electromotive force is acting inside the sun. The sun is not simple plasma. It is electromagnet, huge electromagnet. And inside of the bottom of convective zone, this is the radiative zone, this is bottom of convective zone, there is every 11 years, the new flux ropes are formed, and then negative polarity, positive polarity, they're formed at the minimum of solar activity, and it takes about 5.5 years until they appear on the surface at these magnetic loops, which are shown, which will be maximum of solar activity. And the way how this field, poloidal field of sun, converted to this toroidal field of magnetic loops, and how after that these magnetic loops become recycled by the sun. So the sun basically, you see in the butterfly diagram, the picture, the sunspots and loops moving towards the equator. So it's fine, but the part of the loop which are located above the royal zone, they're moving towards the poles, and they're leading the leading polarity of sunspots to become the polarity of poloidal magnetic field. So this is called alpha-omega dynamo. Alpha effect allows these magnetic loops travel over buoyancy to the surface, and omega effect distributes these loops and sunspots in different parts, either towards the equator or towards the poles. So what you get beautiful action of solar dynamo. So you had at the start of the minimum, in the north you have northern polarity, and the south you have southern polarity. Then this loop started traveling. In some cases, you might have the north and south poles have the same polarity because this field is slowly migrating. Southern polarity migrating to the north, northern polarity migrating to the south, and eventually, for the next solar minimum, you have polarity swap. So on the north, you have now southern polarity. On the south, you have northern. This is electromotive dynamo in action. And obviously, you see that 11-year cycle requires 22 years if you need to increase the parity of polarity, the same polarity. So this is very interesting, but how we can link? I was doing European grid of solar observation. It was a huge European project in the beginning of 2000, 2002, 2005. We created solar feature catalog. We automatically detected anything you can detect digitally on the solar image. And we thought we will produce automated classification of solar activity through sunspot. It didn't happen. It didn't allow you to do this. It doesn't matter how much data you have. This prediction becomes very personalized and cannot be automated because it has so many different ingredients which are not optimized mathematically. So then we started looking at the magnetic field of sunspots. So this is the sunspot magnetic field because we managed to extract sunspots, put them on the magnetogram. So we know how much magnetic field is contained within the sunspot. So we can build magnetic field sunspot. This is a northern polarity, a southern polarity, and compare with the background magnetic field of the sun with poloidal field, what we've shown on the top plot, which came from, this is from SOHO MDI, this came from WVX Wilcox Solar Observatory. And you can see that leading magnetic polarity of sunspot is opposite polarity of the background magnetic field in the royal zone where the sunspot occur. So basically what we see is that sunspots are in antiphase to the background magnetic field. And the correlation, this is the paper we published in 2008. Then we found the sticks. Your nice German astronomer and dynamo person, he already found this for the cycle 21, the similar phase relation opposite, which we also found that whatever we couldn't detect in sunspot, because we have in the background magnetic field, we have the full disk of data, 1,000 by 1,000 pixels. It's a huge amount of data, which reduces error bars. So we could deal much better with this background magnetic field than with the sunspot. So we thought if it is so much related in antiphase, maybe we can use this background magnetic field as a new proxy. So what we did, new proxy, you look at the magnetic field, if you look magnetograms, you can find anything from there. It is like white light. You see the light, but you don't know what wavelength of it. Wavelength is not known. So we look how people detected wavelengths of the light. Remember this prism? When you put on the left-hand side white light, the glass prism splits your wavelength, no wavelength here at all, and suddenly you got this indigo to red, you got waves with the clear wavelengths. So our task was find the similar mechanism which allow you to split magnetic field. And this mechanism is here. Hold a sec. This is principal component analysis. So if you get the data with variance and everything, you run principal component analysis, and you can obtain number of principal components, 1, 2, 3, 4. Each of it will be responsible for some particular physical process, which is much easier to deal with. So this is what we got. When you run this principal component, you got eigenvalues. Those of you who solve one's differential equation of second order, you know that we always solve them with eigenvalues. These are precise method. This is not approximate. This is not artificial intelligence. It's pure calculus. So what we got eigenvalues of this principal component analysis, which came out in pairs. This was a great surprise. We got this in 2010, and suddenly you see the largest principal component, which have coverage 20% plus 19% by variance. On the left-hand side is the variance of your data. They came in pairs. The first pair in here, later we discovered it defined by the dipole magnetic source, these magnetic waves. And this another pair, later we discovered it was defined by the quadruple magnetic sources. So how this principal component looks like? They look like that. So remember the waves? So now we separated waves from the magnetic field magnetogram. We took Wilcox Solar Observatory's synoptic map, full magnetic disk between 30 latitude bands, and the whole time scale we had from cycle 21 to 23. And this is the data which we used. This is what we obtained, 2 components. One component starts in the southern hemisphere with negative polarity, or southern, another northern with the northern polarity. Then they meet in the northern. This is cycle 21. Then the maximum, cycle 22, meet in the southern polarity, and so on. So this is what we got 2 components. What was the problem with it? How to classify it? Luckily for us, at that time, Schmidt and Lipton, they invented very nice software with Hamiltonian approach, how you can mathematically quantify these curves. So you can assign them mathematical formula, which we did. We assigned to these curves the mathematical formula, and then we managed to apply this formula for the next cycle, cycle 24, 25, and 26. So when we compare, this is the principal component defined from the data, solid line, and dashed line, these are principal component we define from the formula. And you see, they're very close to each other. So we predicted cycle 24 at that time. This was the point. These are data we did not use. And the prediction, this is the measurement we found from new data. And this is prediction, and they're very close. It was very encouraging. So we thought, OK, very nice, we got the waves. What is important? Look at that. The waves in the cycle 25 seems like coming in antiphase. The blue wave has maximum, while the red wave has minimum, and especially it happens in cycle 26. They're in antiphase. You know, when you put waves in antiphase, interference, they should cancel each other. This is how they put sound suppression in the large concerts, rock concerts. They put some extra other sound to put it. So we got this on the sun. So how to move it further and understand what we got? We decided to add these 2 curves. We add them together. This is cycle 21, 22, 23. This is what modulated with the formula, everything fine. How to understand sense, what we got? We didn't know yet what we got. So what we decided to look, we decided to compare our summary curve, which we reflected back to the positive. So if you back on the summary curve here, that one is have sign positive because this magnetic field northern polarity and negative southern polarity. What we did, we reflected everything to the positive side. We took a modulus summary curve and then compared with the average sunspot number. So this is black line modulus summary curve, red line is your sunspot number. Suddenly we found that actually they're pretty close, given the fact that we are actually dealing, this is our curve, dealing with the poloidal field, while red line, this is related to toroidal field. And given part they are close, remember we had this correlation between sunspot magnetic field and background field. It shows in this thing. So we thought, oh, maybe we can use this background magnetic field as a new proxy. So what we did, we predicted what will happen with this new proxy for the cycle 24, 25, and 26. And this is what the paper which we published to 15, which was worldwide covered, when we predicted that ground solar minimum is coming because you see the cycle reduction is very, activity reduction in the cycle 26 is very dramatic. But we can compare now, we've done this 2015, now cycle 24 finished, we can put now cycle 24, look at that, this is what we predicted, and this is what we measured. Voila. We got a very nice prediction, so we can trust that this prediction works okay. So now we have a formula. So what can we do with this formula? We can calculate solar activity forward from, this is the 3 cycles we used. We calculate from 2010 to 3200 and backwards to 1200. So when you calculate, what we discovered, that the amplitude of each cycle is coming to a reduction in next cycle. And this is not a unique case. It was a reduction of the amplitude during Maunder minimum. It was 370 years ago. It was reduction in the Wolf minimum, which was in this 13th century. And we were at the verge entering ground solar minimum 2015. Of course, 2021, we already entered it. And indeed, it arrived just in time. So this is the prediction which you can find. This was reported in Llandudno, National Astronomy Meeting, and RAS put the press release and many other papers. But what is beautiful, that we have now this formula. Ensure that it works. We can calculate this formula now backwards, not to 1200. We calculated back to 1000 before Christ. So we see it here. This is the Homeric minimum, Oort minimum, Wolf minimum, Maunder minimum. We also express that Spörer minimum actually was not the real minimum. It was the increase of the background radiation because of supernova Bella Jr., which happened in 1280, which caused this and a lot of disease in the Earth in the 13th, 14th century. So this is what we managed to produce. And what it comes, that these oscillational bump ground solar cycles are not unique. They keep repeating each other over the millennia. So this is a normal life. This is how sun operates. It produces these 2 waves in the solar interior, somewhere at the bottom of Tacocline line, and somewhere on the close to the surface. They interfere. Sun works tirelessly, and it doesn't even recognize that on the surface, we don't see much solar activity because of interference of those waves. And this effect, when amplitude is decreasing, everyone knows trigonometry. So it is like you have sum of 2 cosine A plus cosine B. You have 2 waves. Remember, we detected 2 waves. If you apply sum of cosine function, you get result 2 sine A plus B by 2 multiplied by sine A minus B by 2. A plus B gives you the period of oscillation of 11-year cycle, but A minus B gives you this envelope curve, which put oscillation grand solar cycle. So this is beauty of it, that period of grand cycle about 350 or 40 years, because some cycles become longer, some cycles become shorter. You see, this is longer cycles, shorter but more powerful. And what you have, if you compare, we compare where this grand cycle occurred, in most of them, apart Spura, actually coincide with the well-known grand solar minimum. So what you can do, we actually did a comparison of our curve, modulus curve. We are now in the process doing it. It is not yet published. You are catching the science straight from the computer. We prepare. But this is the red curve is sunspot numbers from the solar index, and green curve is our summary, modulus summary curve. And you see for the whole 100 years, it fits pretty well, given that these are different kind of magnetic field. This agreement comes in the beginning, the middle of 18th century in here, but when you see that at this time, there was very limited number of observations. It was not possible to recreate correctly. When we start correcting this data to this one, because this eigenvalue which you found from magnetic field, you can do corrections for this, but you have to correct the whole eigenvalue. If you correct, you start missing this the minimum which come there and another minimum there. So obviously, the correction is questionable, but technically, by curve fitting, we can do this correction fully. But the problem comes with much later with this correspondence into a few millennia. So we are not so keen to do this correction. We probably will publish this data and suggest to use eigenvalues in addition to sunspot numbers. So from this one, we saying that grand solar minimum has arrived. We have a new proxy of solar activity, principal component, 2 principal components, solar background magnetic field, which produces double dynamo waves. So instead of a single wave, we discovered that the sun produces 2 waves in 2 different layers, and this allows to understand all the occurrence of the grand solar cycle with the period 350, 400 years. And obviously discovered that next grand solar minimum is upon us. But what is beauty of this discovery when we separated all other waves and got only dipole magnetic waves, that we now can apply, dynamo formula, Parker dynamo. Instead of 1 layer, we use 2 layers. I'm not explaining, giving you this equation, just to explain you that this is, we have one equation responsible for the toroidal magnetic field formed from the poloidal, and another equation shows how the toroidal field is converted through the vector potential into poloidal back. So you see the process is very difficult, but what is surprising, how on earth these 2 magnetic fields become so close? So given the formula, you can think, oh my God, this closeness of the data and observations and sunspot become very interesting. So when you put this, knowing this now model, we can actually reproduce our summary curve with the dynamo models. If any one of you follow dynamo and solar activity prediction, you know very well that people cannot predict even 1 cycle of solar activity until this cycle started. But look at us. We predicted solar activity. We were in here in 2010, somewhere here. We predicted 1,000 years forward, 1,000 years backwards. And basically, Elena Popova, she did simulations for us from Moscow. She managed to reproduce pretty nicely shape of the envelope curve and the amplitude of this. Of course, they're not ideally. Probably we need to work better with the dynamo numbers, meridional circulation, and other. But the beauty is that it turns out that in these two layers, the difference in meridional circulation in 1 kilometer per second allows you to have this nice ground solar cycle. So it is doable. It is not something you need to put thousands, millions difference. It is what you observe. And people actually, Zhao et al., they confirmed 2 layers from helioseismic observations by SDO. So now we predicted also the butterfly diagram for Mount the minimum. As you can see, 1700 when you have sunspot. This is what Elena got sunspot. 1710, you got sunspot. And this is when you don't have sunspot. So what we're now interested, what will be for this ground solar minimum? This is what will be. So what we will have between in cycle 26, where there practically will be no sunspot. Cycle 25 and 27, they will have some remnant sunspots. Not much, but they will have some. And to tell you, to prove my point that we entered ground solar minimum, this is the data from Solar Observatory in Belgium. And the green line is the cycle 25 number of spotless days. What you can see that this line is sharply increases greater than it was at Dalton minimum 100 years ago, cycle 15 and 24. So obviously we are at the start of ground solar minimum, and the data confirms it. So now what we want to do, we look what the Earth does. So what we got in the Earth, we got unprecedented winter storms hit British Columbia in 2020, 2021. We entered the ground solar minimum. This is now even NOAA saying that indeed we entered ground solar minimum. They do not deny. Some people repeated our result. Kitiashvili from NASA in 2020 published paper repeating our result, and Obritka et al., they repeated also result with the same magnetic field. So definitely NASA seeing this upcoming solar cycle as the weakest in 200 years, and what will lead to the global cooling period, very global cooling. So why we think it will be global cooling? Let me remind you what happened in the ground solar minimum and Mount the minimum. So this is the irradiance curve reproduced by Lin et al. Show this is the ground solar minimum, 1620, 1710. The solar irradiance dropped by 3 watt per square meter from 1366 to 1363. And the similar temperature in the ground solar minimum, drop of the temperature was about 1 degree. And similar happened in Dalton minimum. Every time you have longer minimum Dalton, every 100 years, the temperature dropped very dramatically. Here the calculations have dropped solar irradiance during Mount the minimum. So we couldn't expect the similar. We cannot expect different. And this is what we get. The surface temperature of the Earth was reduced during Mount the minimum. This is actually from the paper Schindel et al. 201 in the Science. Maybe you've forgotten. Just go and read again. Because this guy done first comparison how the Earth was covered. Some places increased the temperature, but Northern Europe and Northern America, they had a huge decrease of the temperature. Europe and North America went into deep freeze. Alpine glacier extended. Sea ice crept south from Arctic, and rivers were frozen. So I don't know whether we get the full extent, because the current ground solar minimum is 3 solar cycles versus 6, which was in Maunder, but it still will be cold. What we get, what is happening, drop of the temperature actually was related to drop in abundances of ozone layer in atmosphere, and what it leads, drop of ozone layer, leads to this fluctuation, what you mentioned a few times, of this northern stream. These jets change their direction, allowing the cold air from the north to be propagating towards the south. And on some reason, the jets are mostly located in the northern hemisphere, Europe and America. So this is what caused giant wiggles in the jet streams and kicked North Atlantic oscillations and produced to Europe remained unusually cold. And this is what we would probably expect in the current ground solar minimum. This is the snow in Carpathian Mountains in Ukraine in July 2020. We had snow in Amman, which never, in 2020 January, and temperature 2 degrees, and we never seen it before. So this is what early snow Canada, many of you have seen the snow, the coolest Arctic ice increases, coldest winter in Antarctic. So this is, indeed, we are verge of the ground solar minimum. So we got ground solar minimum. I explained these points, but what to do with terrestrial temperature? But the point, if it is ground solar minimum, why IPCC doesn't pay attention? They don't pay attention because the temperature is indeed increasing from Maunder minimum to now. And it is actually a Cassofo result, this straight line and oscillations. This is what IPCC original prediction. Now they reduce it much lower. But the point what they have, this it. So this is your solar activity shown in here, which from cycle 21 started decreasing. But the temperature is still increasing. In what their point was, if the sun affects it, then the temperature should be increasing. Solar activity should be increasing, or temperature decreasing, but it didn't happen. So this coincided that we done the second paper, we done the prediction of this summary curve for 120,000 years backwards. And what we found that our actually ground solar cycles come in number of 5. 1, 2, 3, 4, 5. They have nearly similar shapes. We were very curious why they come in 5s. So we got oscillations of the zero line. So we have 11 years with one polarity, 11 years with another polarity. You get average from all these 22 years, and this put your number on zero line. So we found that the zero line actually is not straight. It oscillates like this blue line. And the period is very rigid. It's about 2,000, 2,100 years. We were very surprised, what is it? And then you look at the measurements of solar irradiance, and it turned out the carbon-14 in trees shows similar period. And it was Stein-Hibler et al., 2009, 2015, this period called Holstad cycle, 2,200 years. So it was such period, but what causing it? So in order to do this, we see where we were in the current status of the period. So we look at the current status. So this is Maunder minimum. This is our 2020. We are somewhere here. So this is the summary curve. You see this grand solar minimum coming here, over there. This is the inclination of the increase of the temperature, which comes close to the inclination of the increase of the zero-line magnetic field. And if you put the solar irradiance, it basically follows our summary curve or of the baseline. So what we did, now you look at this black line is this straight line in here. So we ignore all this fluctuation, we get baseline increase of the temperature, and it turned out that increase of the temperature comes in line with the oscillation of this baseline. So it has to be some very periodic project which imposes it. And this project, actually, this process is actually solar inertial motion. When the sun, all the planets, they move around the barycenter of the solar system, which happens here, and the sun moves also around the barycenter of the system. So basically, you can have, there are simulators, everyone can download and play the simulator to see where the sun will be in particular year, what will be the distance. So when you look at this, so the sun wobbles around the barycenter, it doesn't sit there. When it wobbles, it becomes either closer or further from the orbit of the planets. Yeah, I need it there. So what we've done, we look at this. When we published this paper, anthropogenic global warming people were absolutely furious because we suggested there is a hidden energy of the sun which they've forgotten to take into account. They retract the paper 2019. In 2020, sitting on the lockdown, I downloaded ephemeris of the Sun-Earth distances in the millennium 600, 160. The blue is 600, 100, 1100, 1600. And this is in the current millennium from 1700 to 2600. What you see, that the distance between Sun and Earth is consistently decreasing with every year of this millennium. And what is very interesting, that your perihelion is not in December. You know, this year perihelion was on the 5th of January, not 21st of December, as they teach you. So this is basically published in my paper and the book chapter in here. You can photograph and download chapter for free. And it shows you, this is the aphelium, which shows here, in previous millennium, it was 23rd, 24th December aphelium. But in the current millennium, the aphelium was in July. So this is what happened. I published also the differences between distances of the sun and Earth. But the main thing comes, what solar irradiance, I'm coming to the end. What I say, I will put this slide later, I explain. So basically, what is happening that perihelium and aphelium move from the major axis to the intermediate axis because of this solar inertial motion. And what it produces, the Earth doesn't follow the sun as Ken Rice and other AGW people. Actually, the sun becomes closer to the Earth, and this is what produces heating. And the heating, which produced by the sun, is shown here. So if you take average, you have the distance. I can calculate how much heating comes from the sun with some normalization. We took normalization, which gave by Lin et al. 1700. If you take average per month, the increase of the irradiance from previous millennium was about 1.5 watt per meter. But if you take daily measurements, the increase of the solar irradiance is about 20, 25 watt per meter. So you cannot do averaging. And this is what the main thing is, that solar forcing is much stronger in 16 to, yes, finished. We need it there. So this is, I skipped the one about radiative transfer. Yeah, well, okay, I'll leave it for Q&A, and this is conclusion. Basically, 2 slides missed, but if you ask question, what I did, we found the extra heating which come from the sun. Now the question, how AGW people managed to put in the model that the heating come from CO2? They need to do something in aero. If you ask me a question, I will answer. I have prepared this slide. Thank you very much.
Maria, Valentina, thank you very much for this very insightful talk. So wir haben genau jetzt noch 4,5 Minuten für Fragen und dann ist vorbei. Ganz kurze Frage, and we only have really 5 minutes in total for the whole Q&A session now. Okay, who is the first? Was it so exhausting? Okay, good.
Thank you very much for this fascinating talk. I have one small question. It's only a technical question on the principal component analysis. You extracted 2 components that explained about 40% of variance, if I got it correctly. But did you try out to use more components? I know it's you're advised not to use eigenvalues below 1, but I think that's only a rule of thumb. And did you try to use more components?
It's a very good question. We just submitted a paper using the quadruple and sextuple components. As soon as it passes through, I will report you. Results are fascinating. The other 2 components related to solar activity in different indices. So the PCA is absolutely ideal tool to separate the processes. I never thought we will get it. So it's a good question. We are in the process of implementing.
Thank you very much, because you had a very convincing presentation, and I would like to ask something not specific, but I would like to ask something very personal, because you are showing this which is absolutely against the IPCC. How they attack you personally, because somehow they must fight you because you are saying something which is against their basics.
Yeah, this is what happened when we published paper 219 in scientific report, Nature Scientific Report, and about magnetic field variations. We didn't calculate the solar irradiance. We only guessed, in one tiny paragraph, we guessed that the solar inertial motion would cause this period and increase the solar irradiance. It was just tiny guess with 5 lines. For these 5 lines, they retracted our paper. So basically, they literally indicated that I hit the nerve. And I never had the paper retracted before. So I was very upset. And it was 4th of March. And 23rd of March, they put UK on the lockdown. So you sit at home, pitying yourself, and think, OK, I will not be pitying myself. I download ephemeris of Sun-Earth distance. I didn't know what I get, because they tried to persuade all these guys who do celestial mechanics. They show me the plots that the Earth follows the Sun, like a pet follows the owner. I said, it could not be happen. All the other planets traveling about the barycenter. Exoplanets are designed to find, knowing that the star is wobbling. If star is wobbling, it means that the star has a planetary system. So this is where they look for exoplanets similar to Earth. Every astrophysicist knows this, and only in solar physics or solar terrestrial physics, they just deny it. So this is why it was very motivating. I downloaded, produced this chapter. I published beneath the paper our objection and link to the chapter that everyone see that they like. I demanded them to send me apology and remove the retraction. They refuse to do so. They're afraid. So what can I do?
What can we do? Valentina, thank you very much. Yeah, what can we do? Okay, what can we do? Wir haben jetzt noch einen kurzen Beitrag von unserem Präsidenten, Dr. Holger Tuss. Und dann, ja, das hören Sie am besten selbst.